Okay, now let us start question number 4. It is about collagens. We have two metal balls, and both of them are the same mass, which is 50 grams. Also, they have initial velocities and final velocities. Let us see. The mass of each of them is 50 grams, 50 grams. The first ball velocity is 0.4 meters per second. Initially, V2 initially is equal to minus 0.3 meters per second. Minus, it is because the direction in negative x-axis. Okay. Now, after the collision, the first ball, it has just the same mass. It will not change. They will not come together. But its velocity is negative 0.7 meters per second. It go to that negative x-axis. But the second ball, I think it will go on the positive x-axis, but we don't know how much the speed. It is not required. That second. It is simple that we need to find the final velocity for the second ball. Okay. We need to know this is elastic collision. In elastic collision, we have total momentum should be, linear momentum should be conserved. That's mean momentum before initially is equal to momentum finally. For elastic collision also, we have the kinetic energy is conserved. That's mean the kinetic energy initially is equal to kinetic energy finally. We can use the equations of the momentum and we can use the equations of kinetic energy initially and finally to solve this problem. Okay, do you like to use the momentum equations, which is just simple mv is equal to momentum and half mv squared is equal to kinetic energy, which is simple to us to use mv or the squared value of the speed? It is simply to use that momentum. Okay, now we need to know the momentum initially is equal to momentum finally. The momentum initially is composed of the momentum of two balls, so it is equal to the momentum of the first ball P1 initially plus the momentum of the second ball initially, and it will be equal because it is conserved to the first momentum to the first ball momentum finally plus the second ball momentum finally. We need to find this value to find the velocity. Okay, the momentum formula mv. Okay, I'm talking about the first ball m1 v1 but initially plus p2 initially. P2 is m2 multiplied by v2 initially also is equal to P1 finally. P1 for the first mass M1 finally means the final velocity for this mass plus P2 finally. P2 mass 2. The P means I need the velocity also for the second mass, but finally we don't know this velocity. We need to find it. Note that the mass M1 and M2 are the same. If we convert 50 grams to kilograms, then it will be 50 grams. We need to multiply it by 1 kilogram over 1000 gram. This will cancel and it will be 50 over 1000. This will be equal to 0.05 kilogram. Okay, so I put it in kilograms. Now you see that we have the same mass multiplied in each term. What if we divided all the terms on this quantity, which is 0.05? I will divide this term, this term, and this term, and this term. That means I need to divide all of my equation on this number. This will cancel from here and here because this will be over 0.05, 0.05, because this will be distributed. this will be distributed like this. For each term we have 0.05. This will cancel with this. This will cancel with this. So we will have finally 0.4 plus -3, negative 0.3 is equal to 0.5 is gone. Now we have negative 0.7 plus V2 finally. Now just bring this to the other side. We have here positive 4.4 minus 0.3, which is equal to 0.1, and this negative sign will be positive in the other side. It will be positive 7. This is V2 finally. So we have V2 finally in positive x-axis 0.8 meters per second. Simply, it is just one sheet. We need to use the momentum formulas.